Hello, welcome to my presentation on comparing multiple models for section header classification with feature evaluation. I'm Ronnie Pipolia, working with Paul Hyder and Stepan Maestri. We're from MUSC in Charleston, South Carolina, which, for those of you that don't know, it's in the southeastern part of the US. So what did we do? We used a reference corpus of 86 clinical notes. We took those notes and we fed them through an Apache UEMA pipeline with UEMA Fit. We used CTAKes for sentence boundary detection to generate sentences. Then we used Weka to train and run models that we needed using the different classifiers that we were evaluating. The classifiers that we evaluated were SMO using SVM, the J48 decision trees, the random forest, and naive Bayes. We aimed for a two-pass classification system where we would train a model to detect if a sentence was a section header or not, and then another model would take all of those that were determined to be section headers and classify them into one of 39 section headers. The features involved for the section header detection task were the presence of uppercasing, the presence of title casing, and the strings for the sentence and punctuation. Both of the strings were filtered using a string to word vector, which was available in Weka. For section header classification, a few feature sets were evaluated. The features from the detection task were included in all of the sets as a base set. The first set that we looked at included the base as well as features as well as the feature of relative position of the section header as a percent of the total sentences in the note. The second set included the base features as well as the number of sections detected in that section in that clinical note. The third set included base features and included the previous two section headers as well as the last non-subsection section header. Finally, the last feature set just included all of the features that we discussed. So what did we find? So before we start, it's important to note that all of the evaluations were done using 10-fold cross-validation. And so when we look at our section detection performance by classifier in table 1, we could see that SVM/SMO had the highest recall. However, random forest had the highest precision and F1 measure. When we look at section classification performance by classifier in table 2, it's important to recognize that the evaluation was done assuming the ideal upstream performance, meaning that all the section headers in that clinical note were detected. And so the macro average consistently had lower performance compared to the micro average performances in all of the classifiers. You can also see that the SVM had standout performance in recall and precision, followed up by the naive Bayes and then the J48 decision trees and then the random forest. In our efforts to explore that low macro average performance, we looked towards our corpus. When looking at the F1 measure by class for each of the classifiers, we can see that aside from investigations and results, the vast majority of classes had an F1 measure above 0.8. If we just look at the average F1 measure of classes with lower than 20 instances, we can see lower performance on average with each classifier. So when we evaluated different feature sets and its performance using each of the classifiers, we can see that SMO slash SVM is consistently outperforming the rest. And that relative position shows an increase in performance for the SMO SVM, while all the other feature sets show decreased performance using the SVM SMO classifier. So what did we learn? First, while random forest had a better precision and F1 measure in the sentence detection task, the SMO SVM had a better recall, which is more useful for that task. And then also the SMO using the SVM had a better all-around performance in the other tasks. Second, the relative position of the section header was a strong feature that showed us an increase in performance in the section header classification task. Finally, we believe that the use of the section headers that showed up infrequently in our corpus, so roughly less than 20 times in our corpus, was the cause of our low macro average compared to our micro average performances. In the future, we hope to use different corpuses to evaluate the generalizability of our findings, and we hope to evaluate the end-to-end performance of this two-pass system. Thank you for coming to my talk. There's my email, and then this work was supported in funding from Procori. Thank you.